So, today we're going to get into a story that probably sounds familiar to a lot of you. It all starts with what seems like a pretty straightforward idea: building a simple electrical panel. But as we're about to see, this project turned into this whole unexpected deep dive into the world of professional standards, safety, and, well, doing things the right way. And this quote right here from the builder themselves just perfectly sets the stage. This is a story about discovery, a few tough lessons learned along the way, and a big realization that the space between a weekend hobby project and a professional, safe assembly, it's not just about making the wires look neat. It's a whole different mindset. All right, so the goal was simple enough, right? A low voltage control and distribution panel for a home workshop. But right from the jump, from the very first decision about what parts to buy, this so-called simple build started to get complicated. It basically turned into a masterclass on exactly why all these professional standards even exist in the first place. This table just lays it all out so clearly. It's that gap between what you think you know and the engineering reality. Assuming any old metal box will do for an enclosure, well, you're totally ignoring things like heat dissipation and mandatory safety clearances. Or thinking documentation is just some optional step at the end. That's a recipe for a system that nobody can ever maintain or certify. Every single row here was a potential disaster that was only avoided by learning to think like a pro. So the first big roadblock, the first major wake-up call, it happened before a single part was even ordered. The builder had this realization that you can't just go online and pick components that look good. First, you have to learn the language of international standards. And that meant getting up close and personal with the IEC. And here's the first critical lesson, and it's a big one. The builder, and honestly, a lot of us, kind of thought IEC was just one single giant standard, but it's not. It's the organization, the International Electrotechnical Commission, that creates this whole family of standards. Just understanding that one little distinction, that was the first real step out of the hobbyist garage and into the world of professional discipline. And once you dig in, you find the key standard for this project was IEC 16439, figuring out its two-part structure. Part 1 for the general rules and Part 2 for the specific applications. That had a huge immediate effect. It actually forced the project's very first complete redesign. Suddenly, the plan had to change to include a bigger, properly spaced enclosure, all for safety and compliance. This new knowledge wasn't just theory, it turned into action right away. Instead of just grabbing a wire stripper and going for it, the builder created this professional verification checklist. And look at it, see number 5 there? Torque check documented. This wasn't about busy work. This disciplined habit paid off almost instantly. It helped catch 2 incorrect assumptions about breakers and even a mislabeled neutral terminal, all before a single volt of power was applied. This quote came from a real aha moment. It happened while dry fitting a flexible bus bar. The builder noticed that the bus bars had way too much flex when they put a little force on them, simulating what happens when you pull heavy cables. And that's when it just clicked. Standards aren't just about making sure electricity flows correctly. They're about ensuring the mechanical strength to survive in the real world. Okay, so after getting a grip on the international standards, the project's focus shifted. It was time to look at things from a US perspective. And that meant it was time to wrestle with a whole new set of rules from UL and the National Electrical Code and, clear up some really common points of confusion. One of the very first hurdles was just language. What are we even building here? Is it a switchboard or an industrial control panel? They sound kind of similar, but understanding the difference between UL 891 for switchboards and UL 508 for control panels was absolutely critical. It not only corrected the builder's terminology, but it immediately pointed them toward the right components for the job. And then we get to this moment of brutal honesty. So the builder had put together a prototype with all the best components. It looked absolutely perfect. But when they sat down to actually create the documentation for it, they realized something massive was missing. And this was the really hard lesson. A beautiful, neatly wired panel is completely useless without the engineering record to prove it's safe. The design logic, the component ratings, the short circuit calculations, that documentation isn't just something you do at the end, it is the proof of a safe design. Think of it like this. It's the instruction manual for your future self, or for any inspector who ever looks at your work. If they can't make sense of it, you haven't succeeded. This question. This captures that sinking feeling in your stomach that every single builder has felt. It's that moment you realize a piece of common knowledge you were so sure about might actually be dead wrong. And in this case, it led to a near miss involving a critical and dangerously common wiring mistake. So what was the mistake? It was leaving the bonding screw in the neutral bar of a subpanel. Now, that would have connected the neutral to ground on the load side of the main disconnect. That is a serious, serious safety hazard. And the only reason it was caught was because of that new, disciplined, checklist-driven approach that came directly from studying the NEC. So that near miss didn't just cause a sigh of relief. It was immediately turned into a repeatable safety process. This simple 3-point check became the absolute, non-negotiable final step for any subpanel work, making sure that that dangerous mistake could never, ever happen again. So now the journey goes global. After getting a handle on local and national standards, the builders started looking into what it would actually take to design for international markets, or even for hazardous locations. And this opened up a whole new universe of compliance. One of the biggest myths that had to be busted was about the CE mark. It's not some quality badge that a third party hands you. No, it's a declaration from you, the manufacturer, that you've done the work. You've completed the assessment, created the technical file, and you are stating that the product meets all the EU requirements. The buck stops with you. And this lesson really hit home when the builders started thinking about CE marking that beautiful prototype. The physical panel was finished, it looked great, but without a structured design record, a risk assessment, and traceable diagrams, from a compliance standpoint, it was basically worthless. The paperwork is the engineering. And then you have IECX. This is the big one. This is the international system for equipment that's going into hazardous, potentially explosive environments. And the takeaway here, let me be crystal clear, is that this is not a DIY space. It requires a formal, incredibly rigorous certification framework where a mistake doesn't just mean a tripped breaker, it can be catastrophic. So, after all of that, all the standards, all the redesigns, the near misses, we finally get to the real conclusion of this whole journey. The project stopped being about just building a panel. It was about building an entirely new mindset. And this slide right here, this is the cheat sheet the builder wishes they'd had on day one. It's gold. It boils down every key standard we've talked about, from IEC 61439 all the way to that neutral bonding rule, into a simple, plain English answer, and explains exactly why it mattered. It's a perfect roadmap of the whole learning curve. And this is the heart of it all. The final panel was better in every single way. It was safer, it was easier to service, it was documented, not just because it had better parts, but because the builder's entire approach to engineering had fundamentally changed for the better. And you can see that transformation right here in the questions themselves. The questions changed. It stopped being, will it work? And it became this disciplined, professional process. Okay, which standard applies here? What's my verification plan? And where is the documentation that proves what I built is safe? And that leaves us with this final, powerful question to ask ourselves about our own work. It's really the ultimate lesson from this whole journey, shifting our focus from just making something that turns on to truly engineering something that is safe, robust, and reliable for its entire life under all conditions.